This is Dr. Srilatha, Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering, Hyderabad. In this session, I am going to discuss about testing of hypothesis 1. Our module for testing of hypothesis 1, question bank discussion. So, the content is here. The question bank of testing of hypothesis 1. So, testing of hypothesis 1 means test of hypothesis for large samples. In our question bank, we have part A, part B, part C. Three are there. Part A is based on short answer questions. Part B is long answer questions. Part C is problem solving and critical thinking questions. So coming to the part A, our first question is list out the different types of sampling methods. So we have total 2 methods of sampling methods are there. So first one is probability sampling and second one is non-probability sampling. In probability sampling, we have 4 methods. First one is systematic random sampling, and the second one is simple random sampling, and the third one is stratified random sampling, and fourth one is clustered random sampling. So we have 4 methods in probability sampling methods. So first one is simple random sampling, first one is simple random sampling, and second one is systematic random sampling, and systematic random sampling, and third one is stratified random sampling, and fourth one is clustered random sampling. So we have 4 methods in sampling methods. And second one is state the definition of population. So population definition is the human amount or set of all possible outcomes. A set of all outcomes is known as a set of all objects is known as population. So the total number of students in a college is example for population, and sample. So coming to the sample, subset to the population is known as sample. The number of students in a classroom is example for sample. And the definition of parameter and statistic. Parameter is nothing but population and statistic is nothing but sample. Okay, so coming to the next question, find the value of correction factor. So correction factor formula is n minus n by n minus 1. So here we have capital N and small n. And state the definition of standard error. So standard error equal to sigma by root n. So this is the formula for standard error. Find out how many samples of size n equal to 2 can be chosen from the finite population. Finite population is nothing but without replacement. So in without replacement, we have to choose NCN. So here this is capital N value and this is small n value. Okay, so in finite population, we have to choose. Finite population is nothing but without replacement. Okay, so now coming to the next question, find the standard error and probable error of sample size. Sample size is denoted with small n, and the correlation coefficient is denoted with R. Okay, so actually the probable error and standard error formulas are standard error equal to sigma by root n, and the probable error equal to 1.645 into standard deviation. So now coming to the population consists of, next question, if the population consists of 4 members, 1, 5, 6, 8, how many samples of size 3? So here small n equal to 3, and here they have given that capital N equal to 4. So find how many samples of size 3 can be drawn with replacement. So with replacement is nothing but here we have to use infinite population. So in infinite population, the formula is capital N power n. So here we have 4 elements and the sample size is 3. So now coming to the next question, the mean weekly wages of workers are with standard deviation of rupees 4, and the sample of 625 is selected. Find the standard error of the mean. So here they have given that sigma value is 4 and sample n equal to 625. Okay, so therefore the standard error equal to sigma by root n. So we have to substitute all these values here. So that is 4 by root 625. So that is standard error. So next question. So list out the difference between large samples and small samples. So what is large sample? If n is the sample size is greater than or equal to 30, then we can call it as large sample. If the sample size n is less than 30, then we can call it as a small sample. Now coming to the next question. In a manufacturing company, out of 100 goods, 25 are top quality. Find the sample proportion. So what is the sample proportion formula? The sample proportion formula is x by n. So what is x value here? Here x value is 25 and n is 100. So 25 by 100. So now coming to the next question. Find the confidence interval for single mean. If mean of the sample size is 400 is 40, find the confidence intervals for single mean. If mean of the sample is 400 is 40 and standard deviation is 10. That means sigma equal to 10 and the sample size n equal to 400 and mean x bar equal to 40. So x bar equal to 40. So what is the confidence interval here? So the confidence interval is here x bar minus z alpha into sigma by root n, comma. So x bar plus z alpha into sigma by root n, or we can write the confidence interval equal to x bar plus or minus z alpha into sigma by root n. So this is the formula. Okay, so what about z alpha? Here they have not given. No, we have to take z alpha is 5% and we have to take z alpha is 1.96. Okay, so here n value is there, sigma value is there, and x bar value is there. So substitute all these values in confidence interval formula. So now coming to the next question. Find the confidence interval for single mean. If 18 goods are defective from the sample of 200 goods. Okay, so what is the sample confidence interval? So for proportion. So here also same, we have to take plus p plus or minus and the root of z alpha into and the root of n. Okay, so here we have to use we can use the formula is p value. We have to find the p value for using the sample proportion formula. The sample proportion formula is here x by n. So that is nothing but 18 by 200. So now coming to the next question. So find the formula for standard error of sample proportion. We have to write the formula for sample proportion. Sigma by root n. In a manufacturing company, out of 200 goods, 18 were faulty. Find the sample proportion. So this is x value and this is n value. We can write p equal to x by n. Okay. So next one, that is sample proportion formula. Find the sample proportion of one day production of n value is here. The n articles only 50 are top quality. So that means here x value is this one. So p equal to x by n, that is 50 by 400. Now coming to the next question. State the formula for difference of means in large samples. So difference of means in large samples means z equal to, we have to take x1 bar minus x2 bar divided by and the root of sigma 1 square by n1 plus sigma 2 square by n2. So this is the formula for difference of means. State the formula for test statistic for difference of proportions in large samples. The proportions formula is here z equal to p1 minus p2 divided by under root of pq into 1 by n1 plus 1 by n2. Okay, and the last question is find the confidence interval for mean. If mean of the sample of 144 is 150, standard deviation is 2. So the confidence interval. So the confidence interval formula is here. Confidence interval equal to x plus or minus x bar plus or minus z alpha into sigma by root n. So here they have given that sigma value, and this is sample size of 400 is, so that means n value is 144 and x bar equal to 150. So that is the formula. Otherwise we can use x bar minus z alpha into sigma by root n comma x bar plus z alpha into sigma by root n. So now coming to the next question. A population consists of ranks of 5 students based on their performance in a physical test, namely 2, 3, 6, 8, 11. Consider all possible samples of size 2, which can be drawn with replacement from the population. Calculate first one mean of the population, second one is standard deviation of the population, third one is mean of the sampling distribution of means, and fourth one is standard deviation of the sampling distribution of the means. Okay, so here they have given that capital N equal to 5 and small n sample size is 2, small n equal to 2. So what is the first one formula? So we need to find the mean of the population. So mean of the population mu equal to summation capital Xi by n. So here the capital Xi values are these. Okay, so now coming to the next question, we need to find the standard deviation. So before that we need to find the sigma square variance. So variance is nothing but x summation xi minus mu whole square by n. Okay, so summation xi minus mu whole square by n, this is the formula for variance, but we need to find the sigma, that is nothing but under root of sigma square. So now coming to the third case, for the third case, here they have mentioned that with replacement. So first of all, we need to find the sampling with replacement. So sampling with replacement means here we have to take 2, 3. So with replacement means we have to take both the values, that is 2, 2, 2, 3, 2, 6, 2, 8, 2, 11. So like that we have to take 3, 2, 3, 3, every value, 3, 3, 3, 4. So like that we have to take. So for that, these are all xi values. Okay, so but we need to find xi bars. We have to take the average of those values. That means 2 plus 2 by 2. This is 2 plus 3 by 2. So like that we have to take, from that we can calculate xi values. So coming to the third question. So what is our third question? Here we need to find the mean of the sampling distribution of means. So mean of the sampling distribution of means are nothing but mu x bar equal to, this is with replacement, no? So here we have to take n power n into summation xi. So summation xi values, okay, or xi bar values, not xi values, summation xi bar values. So that is the formula for mean of the sampling distribution of means. So these are all xi bar values. We have to write the samples. After that we have to take the averages. Okay, so after that we have to substitute here in our formula. We'll get the mean of the sampling distribution of means. So last question is standard deviation or variance of the sampling distribution in with replacement. So that is sigma square x bar equal to 1 by, in with replacement we have to write n power n into summation xi bar minus mu x bar whole square. So this is the formula, mu x bar whole square. Okay, so that is the mean of the standard variance of the sampling distribution formula. So from that we can calculate sigma x bar, that is nothing but standard deviation of the sampling distribution of means, that is equal to under root of variance of the sampling distribution. So now coming to the next question. A population consists of ranks of 6 students based on their performance in a physical test, namely 5, 10, 14, 18, 13, 24. Consider all possible samples of size 2. So here they have given that capital N equal to 1, 2, 3, 4, 5, 6 and small n equal to 2, which can be drawn without replacement. Without replacement means here we have to take NCN. From this population, calculate mean of the population. Mean of the population is nothing but mu equal to summation xi by n and the standard deviation of the population. For that, we need to calculate variance of the sampling distribution. And the next one is mean of the sampling distribution of means. So for that, we need to write mu x bar equal to 1 by n power n into summation xi bar. And last one is standard deviation of the sampling distribution. For that we need to calculate variance first. After that we need to calculate the standard deviation. So some difference is there in third formula. So that is our third formula is here mu x bar equal to 1 by NCN. Here we have to use NCN xi bar. Okay, so but here in this case we have to take 2 comma 5 sorry 5 comma 10 5 comma 11 without repetition. Here we have to take without repetition, without replacement. Okay, so that is you have to follow and take the average of those values. Those are nothing but xi bars. Okay, so now coming to the next fourth formula, sigma square x bar. So that is 1 by NCN into summation of xi bar minus mu x bar whole square. So this is the formula for variance. So from that we can calculate standard deviation, that is nothing but sigma x bar and a root of variance of the sampling distribution of means. So this is also same. The population consists of ranks of 6 students. So here without replacement, same procedure like our first problem. Sorry, like our second problem. Same like second problem, and this is based on with replacement. So this is same like a first problem. Okay, so same here also we have mean of the population, standard deviation of the population, mean of the sampling distribution of means are there, standard deviation of the sampling distribution is also there. Okay, so coming to the last problem, so this is also same. Here small n equal to 2 and capital N equal to 5. So here also we have to follow the with replacement, with the repetition. Okay, so repetitions are allowed here. So that's why we have to take 3 comma 3, 3 comma. So sample size is 2 now. So that's why we have to take 3 comma 6, 3 comma 9, like that we have to take with repetition, with replacement. Okay, so same like first problem. So now coming to the sixth problem, a population consists of ranks of 5 students based on their performance test same. So here we have capital N equal to 5 and small n equal to 3. So again here we have to use without replacement, without repetition we have to take. The formulas are same. The mean, next coming to the next question, the mean height of the students in a college is 155 and standard deviation is 15. Estimate the probability that the mean height of the 36 students is less than 157. So here observe carefully, the mean height of the students is mu equal to, they have given that 155 and sigma equal to, they have given that 15. And what is n value? N value is 36. Okay, so here we have to find probability x bar less than 36, mean height of the students. So x bar less than 157. So we need to find this one. Okay, so according to this formula, so here we have to use the formula is x bar minus mu by sigma by root n. We have to use this formula. Okay, so here x bar value is this one. Okay, so x bar or z1 equal to x1 bar minus mu by sigma by root n we have to use. So here x1 equal to 157. So from that we have to find the z value. Okay, so from z value we can write the we can find the problem by using the curve. So this is our normal curve. The normal curve is symmetric about z equal to 0 here. So left side we have negative values and right side we have positive values. The total area is 1 and half of the area is 0.5. So based on this diagram we can find seventh problem. Okay, so like that here also same. And in seventh question, a random sample of size 100 is taken from an infinite population having the mean 76 and variance is 256. Estimate the probability that will be between 75 and 78. That means here we need to find 75 less than or equal to x less than or equal to 78. So here n equal to 100 and mean mu equal to 76 and variance sigma square equal to 256. From that we can find sigma value. So the formula is same here. So z1 equal to x1 minus mu by sigma by root n and z2 equal to also same x2 minus mu by sigma by root n. So okay, so we need to find this one by using the normal distribution, the normal curve. Okay, So here also same, the mean of the certain normal population is equal to the standard error of the mean of the samples of 64. From that distribution, calculate the probability that the mean of the sample size is 36 will be negative. So when it will be negative, if x bar less than 0, then it will be negative. We have to find this one by using the values of this one. Okay. So here mu equal to so the mean of the certain normal population is equal to mu equal to standard error of the mean of the sample size. So here they have given sample size is 64 and mu equal to they have given that sigma by root n. Okay, so from that we can calculate the values, and after that we have to find p of x bar probability of x bar less than 0, because this will be negative. Okay, so the formula is x bar minus mu by sigma by root n. So now coming to the next question, a random sample of size 64, that value is n, is taken from a normal population with mean mu equal to 51.4 and sigma equal to 68. Estimate the probability that the mean of the sample will, first one, exceed greater than or equal to, we need to find probability of x bar greater than or equal to 52.9. So here the probability of 50.5 less than or equal to x bar less than or equal to 52.3. So here the probability of x bar less than 50.6. Okay, so we need to find these values. Okay, so by using same formula. So now coming to the next question, a sample of 400 items is taken from a population whose standard deviation is 10. The mean of the sample is 40. Examine whether the sample has come from the population with mean 38. Also calculate 95% confidence interval for the population. So here they have given that small n equal to 400, population whose standard deviation is 30, that is sigma. The mean of the sample is x bar equal to 40. We examine the sample came from the population with mean. So that means mu equal to 38 and 95%. So this is alpha value. So from that we can calculate z alpha. That value is 1.96. We have to take from the distribution table. Okay, so the formula is here x equal to z equal to test statistic z equal to x bar minus mu by sigma by root n. So here we have to use this formula. So before that we have to follow one procedure. So the procedure is, first one is null hypothesis. Null hypothesis is nothing but h naught. So here we have to write some new value, and second one is alternative hypothesis. So that is h1, that is equal to mu not equal to, or we can take mu greater than or mu less than. So third one is level of significance. So here for z alpha value is 5% or 95%, z alpha will be 1.96. We have to take from the distribution table. So next one is test statistic. So here we have to use our formula. So here z equal to x bar minus mu by sigma by root n. And fifth one is conclusion. So coming to the conclusion, modulus of z less than z alpha, we accept h naught. So if modulus of z greater than z alpha, we reject our h naught. So this is our procedure. Now coming to the 12th question, the means of these two large samples of sizes. So n1 equal to, here they have given 1000 and n2 equal to they have given 2000. So members are mean. So this is nothing but x1 bar equal to 67.5 and x2 bar equal to, they have given that 68.0 respectively. Can the samples be regarded as drawn from the same population of standard deviation? Here they have given that sigma value, that is nothing but sigma 1 or sigma 2. Okay, so that is equal to, they have given that value is 2.5. So that means the procedure is same. Here also same, we need to follow the procedure. Our procedure is null hypothesis, alternative hypothesis, level of significance, test statistic, conclusion. Okay, the procedure is same, but the formula is in the test statistic we have to use our formula. The formula is x1 bar minus x2 bar divided by, so under root of sigma 1 square by n1 plus sigma 2 square by n2. So this is our formula. But we know that here sigma 1 equal to sigma 2 equal to sigma. So now next, coming to the next problem, an ambulance service claims that it takes an average of 8.9 minutes to reach its destination in emergency calls. To check on this claim, the agency which issues license to ambulance service has then timed on 50 emergency calls, getting a mean of 9.2 minutes with 1.6 minutes. Examine the claim at 5% level of significance. Okay, so here they have given that some mu equal to 9.2 and sigma equal to 1.6, average x bar equal to 8.9, and what is n value? So here ambulance service check to check the claim agency license ambulance has 50. So here 50 is n value, n equal to 50. So that means here also same, z equal to x bar minus mu by sigma by root n. The procedure is same, the formula is x bar minus mu by sigma by root n. So now coming to the next question, according to the norms established for a mechanical aptitude test, the persons who are 18 years have an average weight of 73.2 with standard deviation 8.6. If 40 randomly selected persons have average 76.7, examine the truth value of the hypothesis, testing of hypothesis H naught equal to 73.2 and so H naught mu equal to 73.2 and mu greater than, here mu greater than 73.2. So here mu equal to 73.2 and sigma equal to 8.6 and x bar equal to, so what is x bar here? X bar is 76.7 and n equal to 40. So same formula, z equal to x bar minus mu by sigma by root n. So next, coming to the next question. So a random sample of 100 electric bulbs produced by manufacturer of A showed a mean life of 1190 hours. Okay, so here they have given that, so this is x bar and this is n1. So x1 bar and that is n1 and this is sigma 1. And the sample of, so this is n2 and this is x2 bar and this is sigma 2 or n2. So sigma 2 or s2. Both are same here, s1. Okay, so here we have to use x1 bar minus x2 bar divided by and the root of s1 square by n1 plus s2 square by n2. Otherwise, we can write sigma 1 square by n1 plus sigma 2 square by n2. So everything is same. The procedure is same. Now coming to the next question, on the basis of the total scores, 200 candidates of civil service examination are divided into two groups. First group is 30% and second group is 70%. Consider the first question of the examination. Among the first group, 40 had correct answer, whereas among the second group, 80 had correct answer. On the basis of these results, can we conclude the first question is not good at discriminating ability of the type being examined here. So here they have given that n value. So and they have given that total value is n1 value and n2 value. And here we have to use x1. They have given x1, x2 values. x1 is 40 and x2 is 80. So we have to use p1 minus p2 divided by under root of PQ into 1 by n1 plus 1 by n2. This is our procedure. So here P equal to x1 plus x2 divided by n1 plus n2. So what is Q? Q is nothing but 1 minus P. We have to use that formula. So next question, a cigarette manufacturing firm claims that a brand A line of cigarettes outsells its brand B by 8%. So if it is found that 42 out of a sample of 200 smokers prefer brand A and 18 out of another sample of 100 smokers prefer brand B. Examine whether 8% difference is valid claim. So here we have to use same procedure. So this is x1 value, this is n1 value. Okay, so this is x2 value and this is N2 value. So here also same, we have to follow same formula. So that is Z equal to P1 minus P2 divided by under root of PQ into 1 by N1 plus 1 by N2, where P equal to X1 plus X2 by N1 plus N2 and Q equal to 1 minus P. So before that, P1 is nothing but X1 by N1 and P2 is nothing but X2 by N2. Okay, so this is a test of hypothesis for difference of proportions. 16th problem and 17th problems are based on test of hypothesis for a difference of proportions. So now coming to the next question, if 48 out of 400 persons in rural area possesses cell phone, while 120 out of 500 in urban area, can it be accepted that the proportion of cell phones in the rural area and urban area is same or not? Use 5% level of significance. So here also same, here we have to use same formula. So this is X1, this is N1 and this is X2 and this is N2. And here alpha value is 5% and Z alpha will be 1.96. So coming to the 19th question. So here they have given that means. So that means X1 bar and X2 bar and standard deviations. This is sigma 1 or we can write S1 and S2. And sample sizes N1 and N2. So what is the formula? Z equal to X1 bar minus X2 bar divided by and the root of S1 square by N1 plus S2 square by N2. So this is our formula for 19th question. And coming to the 20th question, in a big city, 35 out of 600. So this is X value and this is N value were found to be smokers. Does this information support the conclusion that the majority of the men in this city are smokers? So here they have given small p value, that is X by N, and capital P here we have to take 0.5 and Q is nothing but 1 minus P, and the formula is Z equal to small p minus capital P divided by under root of capital PQ by N. So small p minus capital P divided by under root of PQ by N. So this is our formula. Okay, so N value is these 600. So coming to the part C, problem solving and critical thinking questions. So first question is same. So already we have discussed, this is the small n value and this is capital N equal to 4 and the mean of the population, standard deviation of the population, same like here we have to use without replacement. Okay, so same like, so question bank part B, second question, same like, okay. So coming to the, this is also same, okay. So here also we have to use n equal to 2 and capital N equal to 5. Okay, so mean of the population, standard deviation of the population, mean of the sampling distribution, standard deviation of the sampling distribution. So a normal population of mean 0.1 and standard deviation mean x bar equal to, mean population mean is mu equal to 0.1 and standard deviation sigma equal to 2.1. Calculate the probability that mean of the sample of size 900 will be negative. When it will be negative, so x bar is less than 0, then this will be negative. Here n value equal to 900. So here we have to use x bar minus mu by sigma by root n formula. So coming to the next question, a random sample of size 64 is taken from the infinite population having the mean mu equal to 45 and standard deviation sigma equal to 8. The calculate the probability that x bar will be between 46 and 47.5. So here also same. So we have to find 46 less than or equal to or less than x bar less than or equal to 47.5, because this is a continuous probability distribution now. So that's why we have to use this one. Okay, so the formula is same. So now coming to the next question. In this question we have average square feet with standard deviation. And so here mu equal to sigma equal to, so and that they covered by the sample of n equal to 40. Of these, one Gaussian can will be anywhere from 0. That means here also same, we have to take less than or equal to x bar less than or equal to 520, same formula. So now coming to the next question, a sample of 900 members has mean 3.4. So n equal to 900 and mean x bar equal to 3.4 and standard deviation S equal to 2.1, and here has been taken from the large population mean. So mean is mu equal to, and the standard deviation is same. Also calculate at 95%. Alpha equal to here 95%. So here we have to use x bar z equal to x bar minus mu by sigma by root n. Okay, so this formula we have to use, but here we have to follow the procedure. So what is that procedure? We have to write the null hypothesis. From sixth problem onwards, we have to follow the procedure. So that is based on testing of hypothesis. First step is null hypothesis, and the second step is alternative hypothesis, and third step is level of significance, and the fourth step is test statistic, and fifth step is conclusion. So in conclusion, if modulus of z less than z alpha, we accept the null hypothesis. If modulus of z greater than z alpha, we reject the null hypothesis. Okay, so coming to the next question, it is claimed that the random sample of, so here this is n value and this is mean no, so that is x bar. So the sample is taken from the population, so mu equal to, so here they have given that mu equal to and standard deviation sigma equal to, and the level of significance alpha equal to 0.05. So here we have to calculate the values. Okay, so the values we have to calculate by using same procedure, z equal to x bar minus mu by sigma by root n. So then next question. A manufacturer claims that at least 95% of the equipment which he supplied to a factory conformed to specifications. An examination of 200 pieces, sample of 200 pieces means n value is given here, and received 18 were faulty. X values they have given. Examine the truth value of the claim at 0.05 level of significance, alpha value. This is our p value, capital P value. So how to find small p value? By using x by n. So what is capital P? So that is 95%, that is 95 by 100, that is nothing but 0.95. So what is Q? Q is nothing but 1 minus P, 1 minus capital P. Okay, so what is the formula? Z equal to, here we have to use small p minus capital P divided by under root of PQ by n. Now, next question. Among the items produced by a factory out of 500, so 15 were defective. So here they have given that n equal to 500 and 15, x equal to 50 in other sample of, okay, so that is here they have given that n1 equal to 500 and x1 equal to 15, n2 equal to 400 and x2 equal to 20. Okay, so here alpha equal to 5%. Here also we have to follow our procedure, and along with this formula, that is P1 minus P2 divided by under root of small pq into 1 by n1 plus 1 by n2. So where P1 equal to x1 by n1 and P2 equal to x2 by n2, and small p equal to x1 plus x2 divided by n1 plus n2. Otherwise n1 p1 plus n2 p2 divided by n1 plus n2. Q is nothing but 1 minus p. So coming to the last problem, a manufacturer produced 20 defective articles in a batch of 400. After overhauled, it is produced to 10 defective in a batch of 300. Examine whether the machine being improved after overhauling or not. Okay, so here this is x value and this is n value, that is n1 x1. This is n2 x2. Okay, so same formula, same procedure. So z equal to p1 minus p2 divided by under root of pq into 1 by n1 plus 1 by n2. So that is nothing but test of hypothesis for difference of proportions. So this is our module 4 question bank discussion. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.